Flying a drone the last decade has become really easy. You are capable of performing advanced maneuvers like second nature. But have you ever wondered about how the flight mechanics works behind these quadcopters? If that is the case, you should definitely watch this video. Let's use the Air 2S as an example, but the same principle applies for all Autel and DJI drones. And they are all known as quadcopters with a motor in each corner, hence the name quad. This is just a dummy of a single arm that will make it easier for me to explain. Each motor is an outrunner type where you mount the base of the motor to the frame of the drone. The props will be attached to the outer rotating body, which is why they are called an outrunner. So the blades attached to each motor is a very important part of the drone. So the prop is basically made by two identical parts that are designed after the airfoil principle. This is a geometrical shape that will make the air or liquid travel with different velocities on the upper and lower side of the surface, creating a pressure difference. And it's this pressure difference that is being used to create lift. This is the fundamental principle used in all aircrafts, but the principle works underwater as well. So now we understand the purpose of the cross section of the prop. So props are coming in different shapes and sizes. Propellers can be delivered in different lengths, but also the angle of the blade can differ from prop to prop. These are parameters that can be used to optimize the lift force from the motor. There are typically 2 digits printed on a prop that will allow us to identify it. These numbers are typically imperial, and for this specific prop, it's an 8-inch with a 4.5-inch pitch. Now we are talking pitch. The easiest way to explain that is that the pitch equals how far the motor will travel during one rotation in a solid material. And for this specific example will mean that it will travel 4.5 inch for one rotation. The motor on each arm is attached to a ESC, which is an electronic speed controller. This is a piece of semiconductor electronics that will convert the power from the battery pack to something that the motor can understand, allowing for a simple control input to adjust the velocity of the motor. Each motor is plugged into a central flight controller that will take care of the individual power level needed to perform the requested maneuver. Modern flight controllers are equipped with an IMU, an inertial measurement unit that will deliver real-time data of movement and direction of the drone. And the flight controller will typically be positioned somewhere centrally inside the quad. A lot of stuff has been written and can be written about the selection of motors and props and all that stuff. But regardless the choice of the manufacturer, the purpose of this setup is one thing only, and that is to create a one-directional lift force. Because the motor is fixed to the frame and there are no moving parts in the base, there's really no way of directing the one-directional force to any other direction than in the axis of the motor. So if I have to change the direction of the force, I would have to move the whole construction. So now we know how each of the 4 motors are being individually operated by the flight controller. So how does the drone actually apply this in real life when you want to perform certain maneuvers? So how does it take off and manage to hover? Let's assume calm conditions for simplicity. When you increase the rotation of all 4 motors, you will increase the lift force. And the drone will take off when the force exceeds the gravity that is pulling down the drone. When you let go of the sticks, when the drone is airborne, the motor speeds are adjusted so the lift force is matching the force by gravity, letting the drone hover in a fixed height with all 4 propellers rotating at the same speed. The position in the plane parallel to the ground is controlled by GPS and sensor input to the flight controller. Something that we will talk more about later in this video. To keep the drone stable, only pointing in one direction. If all 4 motors were spinning in the same direction, the drone will turn around its own vertical axis due to Newton's third law of motion.
Newton's third law states that when 2 bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. The third law is also known as the law of action and reaction.
This would mean if a motor is providing a certain amount of torque to the rotor where the propeller is attached, the static part will receive an equal amount of torque in the opposite direction. This would mean the net torque will be in the same direction and will make the drone turn in opposite direction of the propeller rotation. This is prevented by spinning the propellers in pairs diagonally in opposite directions, making the net reaction torque 0, preventing the drone from turning. You might have noticed that there are two different sets of propellers delivered with your drone for this exact reason. The same physics apply if you want to yaw or turn your drone. This is done by changing the speed of the diagonal pair of motors, increasing one pair and decreasing the other one. By doing that, the reaction torque will no longer be cancelled out and the drone will turn clockwise or anti-clockwise depending on your stick input. So how do we apply this to make the drone fly? From hovering position, we can now move the drone on the plane parallel to the ground, where pitch is the forward and backward motion and roll is what makes the drone move over a side. These motions are also controlled by motor speed differences. Instead of diagonal motor pairs, the pairs are now formed by the two motors on each side or front and back of the drone. As an example, to pitch the drone forward, the front propellers are running slower and the back propellers at higher speed. This will make the drone tilt forward. How much it can tilt is what you can find in the datasheet called tilt angle or maximum tilt angle. The tilt angle can be viewed as a combined angular lift force that can be split up into two components. The vertical force that should be equal to the gravity for the drone to keep its altitude, and into the horizontal force which will make the drone move forward. This means with larger speed difference, with unchanged gravity will lead to an increased tilt angle, making the drone move faster. The same technique is used to roll the drone, where one of the side pairs are spun faster and the other one slower, making the drone go into a roll motion. This is where the quadcopter design really excels, as the reaction torque produced by the motors becomes zero if you add everything up, despite changing the speed on the propellers to pitch and roll. So the next big question is, how does it actually handle wind? These are very simplified explanations, and the drone flight controller makes use of both yaw, altitude, pitch and roll in combination to keep its position, especially when it's flying under more challenging windy conditions. If we take headwind as an example, the only way the drone can combat wind is to create a horizontal force that is bigger than the wind force. If that is not the case, the drone will not have enough power and it will be forced backward. To increase the horizontal force, the only way to do that is to increase the difference between the force generated by the different pair of motors. By doing that, we will automatically increase the tilt angle, as the motors, if you remember correctly, is only capable of doing a one-directional force. The physics are exactly the same when the drone is hovering, where the horizontal force needs to be equal to the force generated by the wind for the drone to keep its position. We rarely see this, as the camera is nicely stabilized with the 3-axis gimbal. In fact, it would be impossible to get any kind of usable footage if the drone has not applied some kind of stabilization. So this was the basic concept of a quadcopter. There's of course a lot more to this to make smooth flying products like the ones we know from DJI and Auto. So if you want to learn more and enjoy this kind of videos, then kindly let me know in the comments below. Also, in the future, if I do produce more of this educational content, I will make sure to collect everything in a playlist that you will be able to access through this card. I hope you liked this video. If you did, then feel free to give it a like. If you didn't like it, feel free to press the dislike button twice. Thank you for watching, and I'll be seeing you around.